So, welcome back student to the next class of complex analysis. We are almost at the end part of our course. So, we studied the Cauchy's residue theorem, which suggests I can do this integration with this recipe So, if we have some region where we have some finite singularity of this function f z, then I can write this total integration of this f z as 2 pi I multiplied by the residue, and how the residue will be calculated and all these things we have discussed elaborately. But the interesting thing is that even we can, using this Cauchy's residue theorem, we can even calculate the real integration. So, one example was given that if we have some form like this, then we can convert this function to as a complex function, and then I can evaluate this integration by taking some suitable contour. Here the contour was taken as the unit circle, so that my z become e to the power of I theta. That was the transformation we make, and also we need to change this trigonometric function cos theta and sin theta in terms of z, and we did it. So, let us continue with that. This is the concept we will going to use to solve this problem. So, let us take another problem. So, the problem is given as 0 to 2 pi 1 divided by 1 plus half sin theta d theta. This is the integration. Let us check whether this is, this is the integration we need to evolve. We need to calculate this integration, and now this is a real integration. You can see the limit is 0 to 2 pi, everything is real here. So, we need to consider this, we need to convert this integration to the complex integration. In order to do that, we need to take our standard contour here, which is the unit circle with z equal to e to the power of I theta. Then from here dz was something, dz by iz was d theta, that we have calculated. Now, we need to change this sin theta and d theta in terms of z, then we have an function. This function will be in terms of z. So, sin theta is nothing but z minus 1 by z divided by 2i. If I take z equal to e to the power I theta, then it comes as z square minus 1 divided by 2i. So, that is the transformation I need to make. So, d theta we will change as dz iz, this part, and sin theta I will change this. So, if I do that, then this integration will be converted to the contour integration, where the function is 1 plus half sin theta is z square minus 1 divided by 2i. D theta will be replaced as dz by iz, this. So, it will be a lengthy calculation. So, let me erase this because I do not need that. I will going to use this part of the board for the calculation, because I do not have much space here to calculate. So, then I need to simplify a bit. It will be 4i divided by 4i plus z square minus 1 d of z divided by I of z. So, here it will be 2 I z. So, sin theta, so let me write it once again, sin theta was z minus 1 by z divided by 2 I. So, it was z square minus 1 divided by 2 I z. So, it should be 2 I z, then it will be 4 I z. I should be careful about these things, because otherwise my result will be completely different. Okay. Next is I need to now factorize this quantity. So, z I seems to be cancel out. So, I have something like 4, my function become a simple function which is 4 plus z square plus 4 I minus 1 dz. So, this is my function. So, this is the function which is a real function in terms of theta. Now, I convert this theta in terms of z, I convert sin theta in terms of z as well, and as a result I am getting something which is completely over z, and I have the contour integration, and this contour is known to me also, it is of unit circle. So, now the next thing is straightforward, I need to just calculate the residue of this function and use just the Cauchy's residue theorem, 2 pi I multiplied by residue, that is all. So, in order to do that, so residue will be at that point. So, this is a quadratic equation, we just need to solve this quadratic equation, 4 I minus 1 is equal to 0. So, my Z12, the solutions, two solutions 1 and 2 will be minus of b. So, minus of 4 I plus minus root over of b square. So, 4 I square, then minus 4 AC. So, this is a minus. So, we have a plus 4 divided by 2 into A is 1. So, just 2. Then let me try to simplify it, 4 I plus minus, this quantity seems to be 4 minus 16 divided by 2. So, this quantity is minus of 4 I plus minus of 4 minus 16 is minus of 12, root over of minus of 12. So, we should have 1 I, and 12 root over of 12 is 4 into 3. So, 2 root 3 is the result. So, it will be 2 root 3 and whole divided by 2. Fine. So, now I can simplify more this. So, I will eventually have minus of 2 I plus minus of root over of 3. So, my Z1 is minus of 2 I plus root over of 3 I, and my Z2 is minus of 2 I minus of root 3 I. So, let me write it here exactly what I am getting. So, this function now factorized, and if I factorized is as z minus z1 multiplied by z minus z2. So, that I precisely know at which point the singularity arises is equal to 0 when z1 is calculated to be this. So, it seems to be minus of 2 plus root 3 I, and z2 is minus of 2 minus of root 3 I. So, we have 2 points where the singularity arises, and we need to find out which of these 2 points are inside the circle, because my contour is here. This is the contour I have with unit circle. So, this value is 1, this value is 1, this value is minus 1, this value is I, and this value is minus I. So, now if I look to these two Z1 and Z2, we can readily find that minus 2 plus root 3 I, this quantity is somewhere here, which is root 3 is around 1.7 or something. So, that means minus 2 plus 1.7 something, so minus of something. So, somewhere here it is sitting. On the other hand, minus 2 minus root 3 I, this quantity is greater than 1. So, mod of these things is greater than 1. So, obviously, it will be outside the circle somewhere here. So, that means my Z1 seems to be inside the circle, and Z2 point, which where we have the other singularity, it is outside the region of this circle. So, whatever the region is there, Z2 is outside. If Z2 is outside, then we should not bother about the Z2. So, residue now I can find. So, this quantity should have the value 2 pi I residue of the function at z equal to 1 point. That will be my result. That will be my result, 2 pi I residue of function zi. Zi means z1 means this one z1, which is minus 2 plus root 3 of I. So, now I will just put this residue. So, residue will be nothing but residue of f at z1 is limit z tends to z1 z minus z1 multiplied by the function. My entire function is this. This portion I have already written in z1 and z2 in this way. So, this function will be 4 divided by z minus z1 z minus z2. So, this will be my residue of the function at the point z1. So, this point z minus z1 will cancel out. Now, if I go with the limit, if I put the limit, then it will be 4 divided by z1 minus z2. That will be my answer. z1 and z2 we have already calculated here. So, if I now say z1 minus z2, it will be just 2 these things minus this. So, it seems to be 4 divided by this minus this, it will be 2 of root over of 3 multiplied by I. I have this quantity. So, this is the residue. So, residue I have calculated. So, what should be the final value of the integration? Then I need to multiply that by 2 pi I. So, I have calculated the residue. This is the residue of the function at z1 point that I calculate, and the result will be 2 pi I multiplied by the residue, that means this quantity, which is 4 divided by 2 root over of 3 I. So, this I will going to cancel out, 2 going to be cancel out, we will have 4 pi divided by root over 3. So, this is the result, this is the result of this integration. So, the value of this integration what I evaluate is 4 pi root over of 3. This is a real integration, and the result that is coming is also real. So, that is consistent with the fact, and we can say that this integration we just transfer into the complex form and then calculate the residue and use Cauchy's residue theorem and get the result. Okay. So, let us go to another example before going to the next step. Let us do another example of the similar kind. So, the next example that is in our hand is something like this: 0 to 2 pi cos theta divided by 3 plus sin theta d theta. So, again I need to convert this in terms of z. So, cos theta is z square plus 1 divided by 2z, and sin theta z square minus 1 divided by 2z1. So, I just convert this to, and my contour is the standard contour I always use for this problem. As I mentioned, this is the unit circle, this is z equal to 0, I have the unit circle. So, z is e to the power I theta, theta is changing to 0 to pi, and this is the contour I going to use. So, this is z square plus 1 divided by 2 of z, 3 plus sine is z square minus 1 divided by 2i, I replace sine, theta I will going to replace, which is dz divided by iz, 2zi not 2i, 2zi and 2z. So, it will be z square plus 1 divided by 2z divided by 6iz, and then plus z square plus 1, and this 2iz will be sitting here divided by iz and dz. So, few terms will going to cancel. So, for example, this 2iz and here iz is there. So, iz will cancel out, this 2 and this 2 also cancel out. So, what I finally have is something like this: the function is z square plus 1 divided by z multiplied by z square plus 6 iz plus 1 dz. This is the function, this is the function I finally have in my hand. So, let us check once again everything. Okay, one sign is there, it should be minus. I can see this negative sign is sitting here. So, this is minus. So, 6 iz plus z square minus 1 and other things are there. Okay. So, again this function should have some kind of singularity. So, let us check where these singularities are. So, obviously the singularity is at z equal to 0, first thing is z equal to, so let me erase this part. So, the singularity at z equal to 0, we have a singularity, that is for sure. Another singularity I need to write it as 0. So, z square plus 6 z I minus 1 is 0. So, the solution if I write is at z minus z1 and z minus z2 equal to 0, then z1 2 like before minus of b. So, minus of 6i plus minus root over of b square, that means 6i square minus 4 ac. So, this is minus, so plus 4, a is 1, c is 1. So, it is just 4 divided by 2. So, this quantity is minus 6i plus minus of root over of 4 minus 36 divided by 2. So, it is minus of 6 I plus minus of 4 minus 36 seems to 32. So, 32 is 16 into 2. So, we should have 4 root 2 I divided by 2. So, Z1 and Z2 is something, Z1 seems to be minus of 3 I plus 2 root 2 I, and Z2 is minus of 3 I minus 2 root 2 I. These 2 points I have as my Z1 and Z2. One is root 3 plus 2 root 2 I, and another is the complex conjugate of this quantity with a just minus 3 I plus 2 root these things. So, now I need to put it here to find out what is I mean which point is outside. So, one point, so let me write it once again here. So, downside is not. So, Z1 is, simplify it, minus 3 plus 2 root 2 I, and Z2 is minus of 3 minus of 2 root 2 I. So, if you see these 2 points, you can readily find that minus 3 plus 2 root 2 I, this quantity is inside, because 2 root 2 is 2 into 1.74. So, minus 3. So, it should be around here somewhere, very close to 0, and this quantity is minus, both the things are minus. So, obviously, it is way out to the, so somewhere here, negative of this quantity is below. So, only this is inside. So, Z1 is inside, this things is outside. So, the residue is calculated only into 2 points. So, these are inside, Z equal to 0 is another residue which is also inside. So, this is inside, Z is 0 is also inside. So, this function I will rewrite as Z square plus 1 divided by Z into Z minus Z1 Z minus Z2 dz. Z square. So, I write this in this particular form. Now, what I will do, I will try to find out the solution of these things, which is 2 pi I multiplied of residue calculate of this function at 0 point plus residue calculate of this function at Z1 point, because Z1 is inside. So, I need to calculate these 2 residue, add this and then multiply 2 pi I will get the result. Okay. So, let me erase this part. So, first I need to calculate residue at 0. So, if I do residue of this function at 0 point is limit Z equal to 0, Z multiplied by the entire function which is Z square plus 1 divided by Z into Z minus Z1 Z minus Z2. This Z will cancel out, and then I can put the limit. If I put the limit, it will be 1 divided by, this will be 0, it is 1, this will be 0, this will be 0, Z1 into Z2. Z1 into Z2, if I calculate, then let me erase this. Okay. So, let me erase this point because it is not required. So, Z1 and Z2 is this. So, that means I need to calculate this point. So, if I take, so it is 3 minus 2 root 2 minus I, this is Z1 multiplied by 3 minus of 3 plus 2 root 2 of I. This minus and this minus will be plus, I will be minus. So, it will be 3 square a plus b into a minus b, it is 3 square minus 3 square minus this square 2 root 2 square. So, which is 9 minus 8. So, it seems to be minus 1. So, the residue that I am getting here for z equal to 0 seems to be minus 1. So, this residue I calculate, and this residue is coming out to be minus 1. Now, next about this residue. So, let me erase this. So, residue of this function at z equal to 1. So, residue of function z equal to 1 is limit z tends to z1, z minus z1 into z square plus 1 divided by z into z minus z1 into z minus z2. So, z minus z1 cancel out. So, now if I would put the limit, I need to calculate only z square plus 1. So, if I put z1 square plus 1, this is 1, and the downstairs it will be z1 multiplied by z1 minus z2. I need to calculate this quantity. So, let us calculate here. So, z1 square is how much? z1 was minus 3 minus of 3 minus 2 root 2 I. So, z1 square is minus 3 square minus 3 minus 2 root 2 square of that. So, minus of 9 minus 3 into 2 12 root 2 and then plus 8, and I will have then minus of 17 minus 12 root 2. So, z square plus 1, if I put z square plus 1, then this quantity z square plus 1, I need to make a plus 1 here. It seems to be minus of 16 plus 12 root 2. I am getting this quantity. Now, z1 minus z2 multiplied by z1. So, z1 is that. So, minus z1 is minus of 3 minus 2 root 2 I, and z1 minus z2 is this minus this. When I make this minus this, I will have 4 root 2 I. So, once I have this minus this, so these 3 will cancel out, only this and 4 root 2 I. Now, if I put it here, z1 is this quantity. So, it is, so z1 multiplied by z1 minus z2 is nothing but 4 root 2 I multiplied by minus of I multiplied by 3 minus 2 root 2. Now, if I put it here, then I will have 4 root 2 multiplied by 3 minus 2 root 2. Okay. Now, if I do this calculation, upstairs it is minus 16 plus 12 root 2, and downstairs if I multiply, then it will be 4 into 3, it is 12 root 2 minus 4 into 2 multiplied 4 into 2 8 multiplied by 2, it is 16. So, again it will cancel out and I am getting plus 1. So, the residue here whatever I calculate is plus 1. So, after doing all this calculation we find that one residue is minus 1 and another residue is plus 1, and if I add these two things I will get the result 0. So, integration of these things after doing all these things I find it is 0. So, here I will like to stop. In the next class I will go with this Cauchy's integral this residue theorem to find out more different kind of integration. So, the next day we will go with this integration minus infinity to infinity fz dz, how to calculate this type of integration. So, with this note let me conclude the class. So, see you in the next class. Thank you for your attention.